Hi, my name is Dr. Kamba. In this video, I will be discussing the unit root test of stationarity and how the test is conducted on a time series data using the eView statistical software. In this series, we will discuss the nature as well as the property of time series data. All right, a time series data is a sequence of data points collected over an equal interval of time. That is, the data is recorded over consistent intervals of time. One of the properties or attributes that makes a data time series is the equal interval between the time an observation is recorded and the time the next and the subsequent observations are recorded. For example, if we take a record or we keep record of our expenditure on food every market day for 10 different markets, would have generated a time series data on expenditure on food. This is because there are equal number of days between the first and the second market, between the second and the third market, between the third and the fourth market, and so on. So this equality in the number of days between one market and the next make that observation a time series observation. Example of variables in economics on which time series data are collected include stock prices, interest rates, exchange rates, inflation, and gross domestic products. These variables are macroeconomic variables because they are the gauge or measures for assessing the performance of an economy. Take inflation, for example. High inflation rate may provide the signal that the economy is not doing well. When the rate of inflation is very high, it discourages foreign investors, it discourages investment in the economy, it discourages aggregate expenditure, aggregate consumption, and of course, the multiplier effect of all this is a fall in national income. The importance of time series data include the following. It helps predict the likelihood of future events. It makes forecast into the future easier. Help understand the causes of trends or systematic patterns over time. One thing that is very important about time series data is that it could be annual, it could be biannual, it could be monthly, quarterly. In fact, a time series data can be generated by collecting the data once in 10 years. This is called decennial data. Example, census data are examples of time series data generated for every 10 years. So let's quickly demonstrate using raw data. Okay, here there are two things. The first in column A is the time from 1981 to 2023. And the second is the variable on which the data is collected over these periods. So in 1981, this is the data for GDP. In 1982, data for GDP. In 1983, this is the data for GDP in that order. So since the interval between collecting the first data and the second is 1 year, the interval between collecting the second and the third data is 1 year, then we say that this is a time series data, otherwise referred to as annual data. Also, these are monthly time series data generated on monthly basis. I have MPR, monetary policy rate, I have treasury bills, I have prime lending rate. You can see that we have data generated for January, February, March, April, May, June, up to December year 2000. So these data are generated for MPR. In January, the data for MPR is this. For treasury bill is this. For prime lending rate is this. Then in February, so there is equal interval, which is 30 days between the time data is collected in January and the time it is collected in February. So this makes it a time series data, otherwise referred to as monthly time series data. We also have quarterly time series data generated 4 times in a year. So what is happening here is, take a look at 2004, for example. There is no observation for exchange rate in January, in February, until in March. So the data collected for March is assumed to be the sum of data for January, February, and for March to give this. So this results to first quarter. We have data for first quarter of 2004 as this. There is no data for April, no data for May until June. So the data for June is assumed to be the summation of data for April, for May, and for June, resulting in the second quarter of 2004. And this is how it is written. Again, there is no data for July, no data for August until September. So the September data is assumed to be the summation of data for July, for August, and for September, resulting in the third quarter of 2004. Yeah, no data for October, no data for November until December. So the data for December is assumed to be the summation of data for October, for November, and for December, resulting in the fourth quarter of 2004. So by implication, we have generated data 4 different times in a year. Data for first quarter generated in March, for second quarter generated in June, for the third quarter generated in September, and of course for the last quarter of 2004, and the data is generated in December 2004. We have the same process repeated for other years, 2005 up to I think 2006. Thank you very much for watching. Don't forget to share, like, and subscribe. Thank you once again.